Greetings, math fans. All right, so this is basically day 6 of chapter 2, and what we're going to do is we're going to cover a different type of compound inequality. Now, if you remember from day 5, we covered and problems and between problems. Okay, that was the first type of compound inequality. And if you guys remember, I emphasized wherever the lines overlap, that would be the solution. So wherever they cross, where you see two lines and they overlap, that is going to be your solution. Well, it's a little bit different for OR problems. Okay, so let me kind of write this out here for you. So again, this is day 6, and we're going to talk about OR problems. Okay, and basically an OR problem, the main thing is what you want to do is an OR problem is wherever you see a line. So it has nothing to do with overlap. It's literally where if you see a line, that is part of the solution. Okay? So I think the best way to do it is just start with a nice little friendly example here. Let's use our old 3, 4, 5. And let me just give you a nice graph here. So I give you a graph like this and a graph like this. Okay? If I ask you, where do you see a line for this problem? All right. Well, first of all, do you guys agree that this is yesterday? This is the overlap, right? Where it overlaps. So I'm not really concerned about that now. Now I'm concerned about where you start to see a line. And do you guys agree? I'm looking at this thing, right? It overlaps here and here and here, but all of a sudden there's a single line here. Do you guys agree the actual line starts here at 3? So that's actually what I want you guys to grab. You got to say wherever you see a line. Super important, wherever you see a line. And so I see a line starting at 3, so that means my graph is going to look like this. If I do 3, 4, 5, my graph is going to start at 3 and go to the right. And that is the solution. That's the graph of this problem. If it's an OR problem, okay? So your final answer is going to look like this. X is greater than or equal to 3. Okay, because that's where it starts. That's where you see a line at 3. So this is what the original problem would look like. Okay, the original problem is going to look like this. So I'm going to write this original problem that you're going to get for homework or in your quiz or test. Okay, original problem is going to look like this. X is greater than or equal to 3, or X is greater than 5. That's what the original problem is going to look like. Okay? So basically what you're going to do here is you're going to, with this information, you're going to draw this graph. You're going to draw both those graphs, and then you're going to look at it and you're going to go, oh, okay, it starts right here, so I can make my graph starting at 3 and going to the right, and then you're going to say, oh, and now if I want to actually come up with this answer, you're going to look at the graph like we've done before, and you're going to say, oh, well, X is greater than or equal to 3. And you come up with your answer. Okay? Really not difficult. Just remember, OR problems is wherever you see a line, and problems, and between problems, that's where it overlaps. Got to get that straight. Okay? All right, so let's do another example here. If I said, let's just start out with just in words here. So X is less than or equal to 6, or X is less than 7. Okay, so you're going to graph it, 6 and 7, and then you're going to say less than or equal to 6, and then say is it less than 7. So where does the line start? Where do you see it? Again, you guys know it overlaps here. This was yesterday. Okay? So, but I don't care about that. So I'm going to get rid of that. So I only care about where it starts. Okay? Or where you see a line. So in other words, it overlaps here, but isn't there a line? Don't you see a line over here too? Right? Don't you see a line? It goes all the way over. And don't you see the line actually starts? So let me erase this here. Don't you see the line actually starts right here at 7 and it goes to the left? So your graph is going to look like this. starts at 7 with an open dot, and it's going to go to the left. That's your answer for the graph. And then you're going to tell me, oh, well, x is less than, because it's an open dot, 7. So that's it. That's all you do. Wherever you see a line, that's going to be your solution. X is less than 7. Okay? Not bad. Let's try another one here. X is less than 7, or x is greater than or equal to 5. Okay? So let's go ahead and graph it. So 5, 6, 7. And it's less than 7. Or it's greater than or equal to 5. So greater than or equal to 5 is here. Now where do you see a line here? Okay, and please don't tell me between 5 and 7, because I'll say, well, yeah, I see 2 lines there. Well, where do you see where do you see 2 lines or 1 line? It doesn't matter. It's wherever you see a line. And where do you see those lines? Well, gee, Mr. Garbus, I see it everywhere. What? So really, here's a line here. It happens to overlap here. Who cares? You still see the line there. And you guys agree? It also, you see it to the right of 7. So you see it everywhere. So what do you think? If you're going to see a line everywhere, what do you think our answer to this problem is? Maybe you guessed it already. It's all real numbers. So all real numbers. So how do you graph all real numbers? Basically, you just put an arrow like this. That represents all real numbers. Okay, because it means everything. Okay, that's not bad. So that happened, that's because the arrows went, one went this way and one went this way. So that's why it's all real numbers, because I see a line everywhere. Okay? So let's do our last case. X is less than or equal to 5, or x is greater than 7. So if I graph this, here's your 5, 6, 7. So oops, we'll do this one first. Less than or equal to 5, and greater than 7. Well, remember, if this was an and problem, what would the answer be? You would say no solution, because they do not overlap. But this does not have to do with overlapping. It has to do where do you see a line. Well, do you guys agree? I see a line from here down, and I see a line from here up. There is nothing right here. Okay, so I don't include that. So literally, even though here, I'm going to get rid of all this red stuff here and blue stuff. Okay, so literally your answer is going to look like this. You're going to say, oh, well, it's 5, 6, 7, and it's less than 5 and greater than 7. Because it's wherever I see a line, I draw it. So it happens to be less than 5 and greater than 7, right? So this is the same, which is okay. You just have to recognize it. It happens to be the same. So your final answer is this as well. X is less than or equal to 5, or x is greater than 7. Okay, happens to be 2 parts to it because it's both. All right, is that reasonable? I hope. All right, so I kind of showed you the scenarios here. You had your first, let me erase this here. Your first scenario was this way and this way. So that means it's from here over is your answer. The next scenario was going the other way, which is no big deal. And so it would be from here to the left. Your next scenario was like this. And that's all real numbers because it covers everything. And then your last scenario was this, where you had a gap in the middle. So basically you don't say the gap, you say, oh, x is less than 5 or x is greater than or equal to 7. Okay? So those are really your scenarios here. So let's do kind of a crazy one. But again, this is OR. Remember, it's an OR problem. So if I did kind of a crazy one here, you might have to solve first. Okay? So I might give you something like, let's say 2x minus 3 is less than negative 9. Or 3 minus x is greater than or equal to, let's say 4. All right. So what are you going to do? You got to solve each one of these for x. So this is like from 2 days ago where you just solve. So remember, I'm going to add 3 to both sides. So you get 2x is less than negative 6. So be careful if you're adding and subtracting negative numbers. And I'm going to divide by 2. So x is less than negative 3. I didn't divide by negative, so I don't switch the inequality. So that's 1. Or, and I'm going to solve, so I'm going to subtract 3 from both sides. So negative x is greater than or equal to 1. Divide both sides by negative 1. What happens when you divide by negative? You switch the inequality sign. So x is less than or equal to negative 1. Okay, so here you are. This is like at the beginning of this lesson now. X is less than negative 3 or x is less than or equal to negative 1. So go ahead and graph it because you need to make a graph. So we got negative 3, negative 2, and negative 1. Okay, so let's graph it. X is less than negative 3. And x is less than or equal to negative 1. Okay, there's the graph. Now, tell me, where do you see a line? Don't tell me where it overlaps because it's an OR problem. If this was an AND problem, you know it overlaps starting at negative 3. But this is an OR problem, so you start to see the line where? You should say, oh, Mr. Griffiths, I start to see the line at negative 1. Okay, so that's what you're going to do. You're going to graph that, and you're going to say negative 3, negative 2, negative 1. You're going to say, oh, well, I guess it starts here, or the line starts there, and it goes to the left, and that's your answer. Pretty easy, right? Wherever you see a line, that's the answer. So on your answer blank, you're going to tell me x is less than or equal to negative 1. That's the answer to this problem. Okay? So really not difficult, but that is an OR problem. Make sure it's where the line starts. An and in between problem are where it starts to overlap. Okay, where it does overlap. So real quickly, if I just did this exact problem, so this exact thing right here, and this was, let's just say it was and. Okay, the difference now would be, you would do the exact same graph, everything would be the same, everything is the same, except you're going to say, where does it start to overlap? Oh, right here. It starts to overlap at starting at negative 3. So you would say, oh, x is less than negative 3. Right, that would be your answer. Okay, everybody agree with that? You'd graph it too, and I guess I can graph it. Let me kind of scooch this down just a wee bit. You graph it at negative 3, and you would, we can put another negative 4, negative 2, and it would be like this. That would be if it was and. Okay? So anyway, the whole thing is back to this guy here is OR problems. Okay, so if I let me just get rid of this because I don't want to clutter it up here. Okay, so this whole thing is OR problem. Wherever you see a line, that's your solution. Got to practice it. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.